Now we are dealing with Mayer's formula. There are different ways of asking Mayer's formula in your question paper. It can be directly the Mayer's formula. Derive the Mayer's formula. It can be asked, find the relationship between Cp and Cv, because this Mayer formula is giving you the relationship between Cp and Cv. I'm talking about molar specific heat capacity in both the conditions. Okay. Or it can be asked that prove that Cp minus Cv is equal to R. There are different ways of asking the question, so you should know all the ways. In your notes, I'll give you in under what headings this formula can be asked, and it is very, very important, and I might also ask. Okay, so see that you are preparing this very well. So when we are talking about Mayer's formula, we are taking 1 mole of ideal gas. Okay, this is A, B, and C. I would like you to draw this diagram in your copy so that when I have to remove it, you will. Okay, I was saying copy this diagram in your register so that when I have to rub this, you are still having it for understanding purpose. Okay. I don't know which light is better. This is okay now. So we are dealing with the Mayer's formula, and we are having 1 mole of gas in this container, which is having a frictionless piston. Okay, the initial conditions is the initial, you can say the condition only that the pressure is P, volume is V, and temperature is T. Okay, so in the first process, what we are doing here is in the B section, we start increasing the temperature of the gas. We start giving the temperature, or we start giving the energy due to which the temperature changes from T to delta T, but we are doing it at constant volume. Hence, when the volume has to be constant, we are putting up some weights ताकि वो frictionless piston उठ ना जाए. So what is happening that the temperature rises to T plus delta T, rise in temperature, volume is being constant. So here in process B, this will be what kind of process? That is, the volume is not being increased. That is the specific heat at constant volume. This will be given as Q1. We'll take it as Q1. 1 mole of gas is taken. Okay, CV into delta T, the rise in temperature. Okay, so this becomes equation number 1 for this. I hope this is clear. 1 mole of gas, specific heat capacity at constant volume into the change in temperature. Now, we leave the gas and we let it come to the original position, jahan uski P, V or T tha. Okay. Now what we are doing is, then it has come to its original position. Ab isko aap bhul jaiye. What we do is, we again start giving it energy, and this time we are not making the volume constant, so hum weights hata dete hain. So what will happen, that the temperature will rise at constant pressure. Now, because there's no extra pressure will be given, as the energy is being given, as the temperature is being raised, the volume is increasing and the pressure is constant here. Okay, so after a certain time, this piston rises up, working against the external pressure. ऊपर से भी pressure है, so it is working against the external pressure, and it has come from its original position and it has been displaced by delta X. This amount of displacement is there in the piston. Okay, keeping the pressure constant, temperature is changing and the volume is changing. So it is very obvious कि यहाँ पे whatever energy will be given to this will be more than in this condition. Okay, because it is this energy, whatever it is given, we are talking about the energy, इसको ले लीजिए Q2. ये दो काम कर रही है. What it is doing? It is raising the temperature also, and it is even working to lift the frictionless piston. Okay, so what happens is Q2 given will be more than Q1. Okay, so we are taking as Q1 plus W. जितना इसको दिया plus, and the work done against the frictionless piston. अब यहाँ पे if you are talking about work is what? The force into the displacement. Force applied to raise the piston into the displacement. Force का formula क्या होता है? Pressure into area and delta X. Pressure into area. Force is equal to pressure into area into delta X. Now area into displacement. will be what? Volume. So we get P delta V. So the work is P delta V. And Q2 को हम कैसे define करेंगे? Q2 will be 1 mole of gas at constant pressure and delta T. I hope this point is clear. Q2, यहाँ जो Q2 है, this is constant pressure, 1 mole of gas into Cp into delta T. So when you are putting all these, this is equation number 2, this is equation number 3. Put all this in equation, sorry, I'll give this equation number 3 and 4. Put this in equation number 2. Q2 क्या दे रहा है? Cp delta T, Cv delta T, Q1 is Cv delta T, and plus P delta V. I hope you can see it. This is the equation. Now we move further. I'm going to rub this diagram and I'll proceed further. So when we move further, from your diagram, please see, from the figure A, we can write PV is equal to RT. Okay? PV and RT were the basic symbols given. And from figure C, the volume is V plus delta V and the temperature is T plus delta T. So from figure C, it can be written as P V plus delta V and R T plus delta T. Now subtracting equation number 7 and 6. When you subtracted PV and PV gets cancelled out, RT and RT gets cancelled out. So from here we are left with P delta V is equal to R delta T, and this is equation number 8. Right. So equation number 8 is substituted in the previous equation number 5. From 8 in 5. What we get is Cp delta T, Cv delta T plus, instead of P delta V, we are writing R delta T. Delta T gets cancelled out. Cp is equal to Cv plus R, or Cp minus Cv is equal to R, where R is the Mayer's constant. R is known as your Mayer's constant. Okay, so in that case, because Cp is equal to Cv plus R, which implies that Cp is greater than Cv. So the molar specific heat capacity of gas at constant pressure, which will always be greater than the molar heat capacity of gas at constant volume. Okay, so these 2-3 things which I need to tell you is that this equation can be asked as Mayer constant, or they can ask you show the relationship between Cp and Cv, or they can ask you prove Cp minus Cv is equal to R, or they can ask you show that Cp is greater than Cv. So these are the different ways in which the question can be asked. For time being, you take this down and be thorough with this. Basically, numericals on this topic is hardly asked, but the derivation becomes very, very important.